What we're going to look at is how we can check for parallelism and how we can force parallel relationships in vectors. So two vectors are considered parallel if they're scalar multiples of one another. So if we have vector A and a vector B, regardless of whether they're in 3D, 2D, 4D, 1D, whatever, they're considered to be parallel if they're scalar multiples of one another. So vector A is equal to vector B, which means or multiplied or scaled by a number k, and let's just say it's a real number in this instance. If this is the case here, then we have the condition where A is parallel to B. Can we read that notation? So if this is the case, where that's the condition for k, then this is true. Now, given the example, show that AB and CD are parallel, where this one is in its unit base form, and this one, what sort of vector is this form? It's not a column vector, it's a row vector. Do we see these often in the state?
No.
Not this state, but it can be applied. So, if this is the case, what sort of condition might we be looking for if AB is indeed parallel to CD? It's a scalar multiple. So we could say if AB is a scalar multiple of CD, where a value of k is a real value, then we can conclude that AB is parallel to CD. So this is my argument here. This is what I need to check for. Now, checking for this, I know that AB is equal to the scalar multiple of CD, CD. Now, subbing the vectors in, my value for AB is 3, 2, 7, where 7 is negative. K is unknown at this point in time, if it even exists, then -9, -6, and 21. Working our way along, we can do it two ways. We can go by inspection here, or we can build three equations. Which way would you like to go, Nick?
Inspection.
Inspection. Okay, inspecting this, is there a value of k that will make this a scalar multiple of itself?
Yeah.
What is it?
-3.
Yeah. By inspection. Therefore, vector AB is -3 CD. And that's simply by inspection.
Is that the right way around?
What do you mean?
Well, if you times CD by -3, you won't get times -9 by 3, you won't get.
Just checking to make sure you're paying attention, Madden. No one else was. Not even Lenny this time. Or was Lenny just letting everyone else have one?
I wasn't paying attention. Oh.
Including me. Alright, so what we see is that CD is a -3rd of AB. Now, if they're parallel, are they allowed to have a negative scalar multiple? Remember, vectors have direction and magnitude. So suppose the vector's going that way, then what we are asserting by this is that parallel vectors usually go like that, don't they? Are they allowed to go
Their direction would be opposite.
like this?
Yeah.
Yeah, because remember the definition of parallel lines is that they never touch and they point in, let's say, similar directions. Now let's say they point in the exact or the total opposite direction. So if we find that there's a scalar multiple of this one, then therefore it must be parallel. So what's our concluding statement here?
Is that parallel?
Therefore-
AB is parallel.
Therefore, it is indeed parallel to CD. All cool? Alright. What about if we were checking to see if something's not parallel? Could we do that?
Yeah.
Let's say. So this is A. What's your favorite letter, please, Isaac?
C.
Show that C, which is equal to a column vector, will go -3 to 10. And E. This one will be let's go -12, 9, and 40. Show that these guys are parallel. Now, again, if these guys were parallel, what sort of condition or what sort of statement could we make? Yeah, they're going to be scalar multiple every time. Yeah. If C is parallel to E, actually I should do it the other way around. If C is a scalar multiple of E, and we'll pick a different version of K, we'll go M, where M is any real number, then what we discover is that C is parallel to E. Is that cool? So writing this out, C, M, E, putting this together, C is -3 to 10. This is going to be M, -12, 9, 40. Now, is there a scalar multiple? Is there any value of M that satisfies this equation here? No. M does not exist, therefore C is not parallel to E. Is that okay? So what I'll do is, if I was going to get a question like this that required me to show whether something was parallel or not, I would build a statement where this is the mathematical condition that satiates this relationship here. On the OneNote, you'll see that I've got it around the other way. It doesn't really matter, even at university level. Your professor might grumble at you a little bit if you do it the other way around, but typically it's a math equation satiates a condition. Yes?
Just for the wording, wouldn't that have to be whether? Because it's saying show that they're parallel. Wouldn't it be show whether they're parallel? Otherwise you have to show they're parallel.
Show whether.
Ah, yeah, I get it.
Yeah.
Show if. Show or whether. I don't think I'm saying whether in the test there.
Is that the right whether?
Would that be right? Because if you're saying show that they're parallel, then
I rarely write that word. It's like,
Is that how you spell that?
yeah.
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 it's like I once saw a kid spell sandwich as a sandwich. I didn't want to be that kid.
In high school.
Show whether vector C and vector E are parallel. Is that all right?
Yeah.
Okay.